Well, welcome to another Thirsty Thursday. Coming to you from a little different setting again tonight. Variety is a spice of life. Well, the reality is still having some issues with the old internet. And I'm afraid if I was out into my regular outside studio, probably not going to be getting the kind of connection we need. I know I've been trying to get this problem fixed for a week now. Not to mention the internet provider, but they bear a strange resemblance in name to the initials of our women's online wellness group, but not to say who it is. But we're still having some issues making sure that everything's connecting up and providing the bandwidth to be able to do this for you. So I'm hoping that things don't flash out right in the middle of all this. But welcome to another edition of Thirsty Thursday. Tonight we're going to talk about an incredibly important topic, something that you've got to learn, you've got to know, because it's going to be one of the major health decisions you're going to have to make in the next 6 to 18 months. There's a little bit of a precursor as to what we're going to get to. Where in my viral, what I call my viral do, or my Corona Kafur, like you, I've not had my hair cut. You know, my wife has been telling me that she really wants to cut my hair. I haven't succumbed to the temptation. You know, that's not, she does a lot of things really well, but I'm just not sure that's what would work out best for me. Now, if they did one of those challenges where you get your hair cut and by your wife and you raise money for charity or one of those kind of things, I might succumb to that. I might do that. Maybe that's something we can start. Maybe that's something the WOW community ought to do, is instead of the ice bucket challenge, we can do the wife haircut challenge. Although in Georgia, it's probably a moot point now, because according to politicians, we're okay to go back and get our haircuts and go bowling. I think I'm going to go out this weekend and get a big old coronavirus tattooed to my rear end. Wouldn't that be great? I think that would be something I could do a Facebook Live showing that tattoo. You know, I've got a lot of mixed feelings about this, and this is not the topic for tonight, but I believe it may still be a little bit early to be opening up barbershops and beauty salons. You know, we're still open in our office, but we're taking all the necessary precautions with the physical spacing, the wearing of masks, the screening of people, taking temperatures. I'm just not sure that's going to be accomplished in every tattoo parlor around town. So I don't know. I've got some misgivings. I'll be honest with you. I'm not going to a restaurant. I'm not going to get a tattoo unless I really just, have too much Chardonnay and decide that big coronavirus on my rear end would look really cool. I don't think there's enough Chardonnay on the planet to make that happen. Let me just say that right now. But I do think it may be a little bit soon. It's going to be interesting. Georgia is turning into kind of this guinea pig test case. I know there's a lot of places around that are doing some similar things, and believe me, I need to get back to work. I'm a small business owner. That's what most small medical practices are. So I'd love to see the economy rebound, and I'm sure it will at some point. I'm just not really sure we're there yet. But again, that's a topic for another day. Tonight we want to talk about vaccines. My goal for this is first and foremost to educate you, to make you a critical consumer, because this is truly going to be a very important decision that you're going to have to make. It's not going to be mandatory. It's something you're going to have to make. And for most of you out there, you are the decision makers when it comes to health in the family. So you actually probably are going to have a big influence on the decision making in your family when it comes to whether or not to do the vaccine when it becomes available, and it will become available. So my goal for you is to cut through a lot of the garbage, to try to get rid of all the tweets and the Facebook posts that talk about people getting vaccines and growing legs out of their ears, or their noses falling off, or all the crazy stuff that circulates about vaccines. And we could spend an hour talking about the insanity of Jenny McCarthy and the people who support her, the absolute fools who have no real understanding of the science behind vaccines. I'm not going to go into that. I'm going with the assumption that the science behind vaccines that have been around since 1798, when Edward Jenner first inoculated people against smallpox by using cowpox. So this is not our first rodeo. I think there's a lot of myths and misunderstandings. In fact, I may have done a whole video, I can't remember now, on vaccines and the importance of vaccines. We'll leave that for another day. I'm going on the assumption, and we'll touch on this a little bit, that the vaccines are safe. And okay, maybe that's a big assumption, and I'll clarify that in just a few minutes. But I don't want to get into the debate about that right now. I want you to understand why it takes 6, 9, 12, 18 months, 2 years to come up with a vaccine. I think it's really important for you to understand that. I want you to understand the miracle of vaccine. I want you to grasp what an amazing thing that this is, that your body does. I mean, it's phenomenal when you think about how this works and the miracle that has been created to produce this. I mean, this is not like an antibiotic that it's something foreign you put in your system and it kills the virus. This is something that stimulates your own body to do its thing, to work, to fight off this stuff. It's the science, and just forget about the science. Just think about the miracle of what's going on. I mean, you're literally talking about millions, if not billions, of these viral particles that are getting attacked by your own immune cells that have been stimulated to fight these things off. I mean, literally, these are two armies clashing inside your system, and that's what's responsible for a lot of the protection. It's also, by the way, responsible for a lot of the problems that someone who's infected with COVID, or I should say, again, let's make the distinction, COVID-19, and I kind of use these interchangeably. COVID-19 is the disease. SARS-CoV-2 is the virus. But when a lot of times the secondary problem from the infection is the response of your own immune system just going ape crazy and creating this thing called a cytokine storm, which leads to the fevers, to the tissue destruction. That's years ago you saw that Girls Gone Wild video, that trashy video that came out. Well, this is like the immune system gone wild. The immunity that we get once we recover from the virus and the immunity that we get from a vaccine is a controlled response, a controlled action against the virus. But still, just it's almost incomprehensible when you break it down to think how miraculous it is that these little cells learn to recognize these viral particles, and we'll talk about that in just a second, about how that happens. But just to think about it on a cellular level, it just blows your mind, the fact that this thing actually happens, that these cells recognize something as foreign and they go in and gobble it up like these little Pac-Men just to protect. I mean, the immune system is one of the most miraculous systems in our body. We would all be dead of cancer years ago if it wasn't for our immune system going around and scavenging, looking for these abnormal cells, recognizing them as abnormal, and chewing them up and dissolving them. And that's essentially what a vaccine is simply a tool to stimulate your own immune system. That's why something like HIV is so disastrous, because it destroys the immune system. So it wipes out your ability to protect yourself naturally from all these things. Anyway, it's just, it blows me away. It really is amazing. So my goal for you is to gain an appreciation for that, if for no other reason, to help you to make the decision at some point when this happens as to whether or not it's something that's going to be right for you and your family. And literally, it comes down to that. It's an individualist decision. I could tell you what I'm going to do. I can tell you what I'm going to recommend my family and my mom and all those folks to do, but it's going to come down to you and what is going to work for you. So I want you to understand that, and that's where I really want to take this today. I want you to remember the viral spiral. A lot of you, a lot of new folks who are here. Oh, and I got to say, by the way, I got a kick out of it. I told you I read every comment that people make. I don't want to acknowledge them as I'm talking, because I'll be like the dog that that has ADD that chases a squirrel, and I'll be looking at the comment. But I read every comment that you make during these and respond to them. And last week somebody wrote on there, "Is this guy a doctor?" So obviously there's some people on we have a pretty broad coverage now, and a lot of people who are not a part of the practice. So I do have to clarify, yes, I am a doctor. I don't just play one on Facebook. I actually went to medical school and have been practicing now for 32 years. So I do want to make sure people understood that before we go into some of these details. I didn't want you to think I was, just like the UPS delivery guy who just figured he'd do something on Facebook. So, viral spiral. You remember those folks who had just joined, you might not remember what I said. What I'm doing to try to get through all this, to try to make it to the other side of all this. And normally we think of spiraling down. Well, this is a viral spiral where you spiral up. And the first is take care of yourself and your family. And there's a number of ways of doing that. Number two is do something kind for somebody else, whether it's somebody you know, a family member, somebody you don't even know. And then number three is find meaning in what you're dealing with. Find some purpose in the anxiety, the suffering, the discomfort. If you can attach meaning to that, then you're going to be transformed when you come out of this. It's going to change your perspective. So this is part of that, taking care of yourself and your family. We're going to get through this, and there's three ways we're going to get through this. It's very simple, really. There's three ways. Number one is the mitigation. And we all know what that is, the physical distancing. Remember, we don't do social distancing. We are connected through the various ways we can socially. We do physical distancing, hand washing, wearing the masks. All that is under the umbrella of mitigation. The second is developing treatments, actually ways of minimizing the infection once it occurs. And then the third leg of this stool is the vaccine. And that's why it's important that we talk about that, because it's an integral part of dealing with this whole issue. All right, so let's talk a little bit about the vaccine. And I promise we're not going to dig deep into weeds, but I know everything I've culled through, a lot of information, and everything I talk about is going to be something that is going to be important to help you make the right decision down the road. So, the key distinction in thinking about vaccines and helping to explain why it just doesn't happen overnight is understanding the stages of development. And it really can be broken down into about 4 or 5 stages. The first is what we call preclinical. And that's where they have to take these substances and test them in animals. And the reason they do that is because we don't like testing in humans before we make sure something's safe. But there are two things that they look for in the animal studies. One, does it even make the immune system respond? And they have to test this in animals who get the disease. For example, they can't test this in bats because bats don't get COVID-19. They harbor the virus, but they don't get the disease. So it'd be worthless to test this in bats. So they have to find animals, and oftentimes it's mice and some other animals that they have easy access to that are what we call immunogenic. So they test in the animals to see, do they get the disease, and then B, do they mount a immunological response? Do they produce these little antibodies, which are these little Pac-Men? Just think of those little Pac-Men that go around and chew up the virus. And that's called preclinical. Then you get it at that point into the human studies. And that's when you start getting into these what we call phase 1, phase 2, and phase 3. And we're going to talk about what each one of those are in just a minute. And then if it passes through those, then we have to start talking about the production. We talk about the distribution and the administration. So it's not just the light bulb goes off and, oh, let's try this, and okay, that seems to work. It's much more involved with that. And you want it to be involved with that because that comes into this safety factor that we'll talk about in just a second. There's almost, I've seen numbers between 74 and 78 vaccines in development. Now, let's understand what that means, because you see that on the news and you think, oh, wow, 78, of course they're going to come up with something. But you've got to understand, of those 78 being investigated as of 1 week ago, there are only 4 who have already passed the preclinical stage. In other words, 74 of those are still being tested in animals to even determine if they can go to the next stage of being tested in humans. So I hope that begins to help clarify. Just think about this. There is a tremendous attrition rate when it comes to vaccines. It's almost, people talk about how many $1 billion it takes to develop a drug. Well, the reason is these pharmaceutical companies have developed thousands of drugs, but out of those thousands, they may have only get 2 that actually make it all the way through and all the way through the testing. Well, the same thing applies to the vaccines. There's a huge attrition rate. You may start out with 100 and only 1 may actually end up being safe and effective and able to be used. It's kind of like the what's that? America's Got Talent. You know, there's different categories of what people do. There's the magicians, there's the singers, there's the people who put pins through their ears, and people who ride bikes backwards, and there's all kind of different categories. When we think about vaccines, there's basically 6 categories of vaccines. So you can make a vaccine 6 different ways, and that's pretty much it. And I think it's good for you to understand what those are. So just like our America's Got Talent categories of the ear pin person and the comedian and the singer, we've got live attenuated vaccines, and don't worry about the words. We're not going to spend a lot of time on that, but just I want you to understand the concept. You've got inactivated virus vaccines. You've got recombinant protein vaccines. You've got DNA vaccines, you've got RNA vaccines, and you've got vector vaccines. So I want to briefly go into those because you've got to understand. You're going to know so much about. You're going to blow people away at the next cocktail party if we ever have another cocktail party. You can do your own Facebook Live and freak people out by all the information that you're getting, and you can have a great discussion with your husband about vaccines and about the different types of vaccines. So, the classic ones that we're most familiar with are the live or the attenuated. And those are the flu vaccines that we always have and always have, the measles vaccine. You could get a little bit of the virus, you either weaken it or inactivate it, so it's really the virus itself. And then you inject it in a human, and of course you've gone through all these studies, and it's a small enough amount that it elicits, the body says, whoa, wait a minute, that's not right, this is foreign, we don't like this thing, we're going to make these little cells that are going to eat it up. And what's so amazing and part of this miracle is those little cells that eat it up, after they eat it up, they don't just hang out and go away. Many cases, they're around forever. They'll last in your body and divide, and they remember when a cell divides and it gets ready to die and it divides to another cell, or it is created in the bone marrow where they create these immune cells, that's passed on. So that immunity, those antibodies, sometimes will persist for life. That's why a lot of times when you get a vaccine, that's all you have to do is get it for life. We'll say, well, why do I have to get a dang flu shot every year? Because the flu virus mutates and changes enough that one vaccine one year may not get all the strains of flu to cover for the next year. So it's a roll of the dice, quite honestly. They determine, okay, well, let's try. We think maybe these strains of flu are going to be the most common next year, and that's based on a lot of science. I'm simplifying it and not mean to be patronizing to these virologists, but they say, okay, here's our prediction. So we're going to put these things into this vaccine, and that's what we're going to mass produce and we're going to have available to all the folks. Sometimes they hit it pretty good, sometimes they don't, and that's why you get a difference in the effectiveness of the vaccine from year to year. One of the things we're discovering about SARS-CoV-2 is that it doesn't mutate as rapidly like the flu virus. It mutates, it changes, but not some of the basic characteristics, which is what the vaccine's going against. So that's one thing that's in our favor. We're not seeing a big change. So the hope is, once this vaccine comes about, it's going to be good for this particular virus forever. We don't know that yet, but there's some indication that that might be the case. So anyway, the flu vaccine is these live or these attenuated vaccines. This has been around since the 1950s. If anybody brings up the autism and vaccine stuff, I'm going to slap you upside with a wet head with a wet squirrel. Just get over it. It doesn't happen. It's been proven as much as there is gravity. If you don't believe in gravity, then you might believe that vaccines cause autism. It doesn't. So just get over it. But if a vaccine like this of live attenuated or the live attenuated for the COVID-19 would work, it'd be great, because we already have the capacity to produce millions of dosage of this. That's what we do every year for the flu. There's so much, the production part of it, the distribution part of it would be a piece of cake. Everybody would have access to it. But unfortunately, the four vaccines right now that are in the works that have made it to human studies. Remember I said everything else was preclinical. The four that have made it to the first phase of human studies are not these kind. They're from the other kind, and I'm going to tell you a little bit about those right now. The third one was what we call recombinant protein viruses, and these are, we already know a lot about them. That's the HPV vaccine is the type, and we're very familiar with that in OBGYN. We know that that's dramatically reduced cervical cancer. The hepatitis B vaccine is this recombinant vaccine. It's been around since the 80s. It's similar to, remember how we talked about the coronavirus is named corona, which means crown, because of this envelope that surrounds it that has these little spikes on it. You know, you've seen those motorcycle helmets with the spikes coming out, and those crazy Georgia Bulldog people with that wear the shoulder pads with the spikes. Well, that's kind of what these little spikes are on this coronavirus, and that's what the cells in our body and our lung latch onto. So what they're doing with this recombinant DNA, or this recombinant, is they're using the proteins in those spikes that make up those spikes, and they're putting that into the animals and seeing if we make the little Pac-Man go around and chew up those spikes, which would be great, because if it did, then that would disable those cells from getting into our cells. Make sense? But we don't have any of those that have passed preclinical stages yet so far. But it would be a good thing. And it's tricky. This one is a little tricky because they've been using this technique for things like HIV for almost 30 years now. And they've not been able to find a way to do it that provided permanent protection. That's why we don't have a vaccine against HIV right now, is because this is a very difficult road, but it's one that is only showing some preclinical benefit in animals for HIV. So we do have some experience with it. We know it works. It worked for SARS and MERS, which are two other coronaviruses, and that's why That's exactly why they're studying it right now, because it did work with similar ones, but we're not very far on with that. But if it works, it's going to take a little bit longer to set up because we don't have the infrastructure to produce that kind of vaccine in as great a amount. Then we'll kind of lump these last three together: the DNA, the RNA, and the vectored vaccines. Those are kind of what we call phase 3 or third generation vaccines because they do something really kind of wild. They take the DNA or the RNA, the map of the cell from the virus, they inject it into the human or the animal, and our cells take that up. They use that DNA as a code to produce the protein. Our body says, whoa, no, this is a bad protein, this is foreign, this is no good. Here come the little Pac-Men, we're going to go after it. Those are the antibodies. So it actually makes your cell produce that protein, and because it's just a protein, it's inert. It doesn't cause disease. It doesn't. It's not. It'd be like taking a steering wheel out of a car. Just having the steering wheel is not going to do much to cause any problem. You can't drive it. Well, that's the way this is. It's just one part, but it's enough to stimulate the antibodies so that when you get exposed to the whole thing, it recognizes it as foreign and it chews it up. And again, we've done this. It's probably one of the most complex, and I say we, I mean, come on. I haven't done it. I'm talking about we in general as far as society. don't listen. I've studied this and learned a whole lot in the last week, a lot more than I ever knew before. So I don't want to misconstrue the idea that I have anything to do with any of this stuff. So I apologize for using the term we, but it's just a literary structure. But anyway, it's new, it's complicated. It was first started back in the mid-2010s to be investigated. In fact, the very first vaccine of this type was produced in 2015 against Ebola. And it wasn't even approved to be used until 2019. So that illustrates even something as serious as Ebola, it took 4 years to get to the point where it could be used in West Africa in endemic areas. But that is actually what the four that are now past animal studies and are being started in clinical studies in humans, all four of them are that type of vaccine. So I think that's very important. There's not the kind of production, there's not the kind of distribution. We don't have the long track record. Remember, 2015 was the first time that this type of vaccine was approved. Yet, we do have a variety of folks working on this. So who are the front runners? Well, again, you got to understand there's a huge attrition rate. Of these 78, it's just like on America's Got Talent. There's going to be a bunch of people competing from different areas, but there's going to be one winner. And that's what's going to happen with this vaccine. There's going to be, out of these 78 or 80 or 90, however end up in the pipeline, there's going to be one that's going to make it all the way because of all the hoops that you have to jump through to not only prove safety, but efficacy, and probably down the road, long-term efficacy. So there's a big drop-off as they go through these testings. In fact, most of the vaccines will fall out in the animal studies and never even make it to human studies. Most of those 70 are going to be gone after animal studies, either because they cause problems with the animals, or they didn't provide the immune response, or animals got sick even after getting it. So that's where most of them are going to actually be culled. And those tests generally take at least 6 months just to get past that. That's the average. And you got to remember, this stuff doesn't just happen. We're dealing with human systems, physiology, and you can't rush that. You can't just inject something and get a response. It has to go through the normal pathways. The miracle has to unfold, but it doesn't unfold overnight. It takes time. It takes time for the response. It takes time to determine efficacy. Of course, it takes time to determine safety. So that's why this is not just an overnight, gee, we know it's a critical part of what we got to achieve, but you just can't rush it. It's like a fine wine. You got to let it age. Thank goodness we don't have to let it age 30 years for it to be effective. But it's critical to understand that this is not like somebody develops a treatment and you can a surgical procedure and you can begin trying it in a more, because it's easier to assess the safety and the efficacy. There's a lot of things that go into this, and it's really for your safety, quite honestly. So, as I said, there are 4 candidates. There are the ones in Seattle, one's in I want to say Pennsylvania, one's in China, worries me a little bit, and one's in Oxford, England. So those are the ones that are now into what we call phase 1 human studies. So what does that mean? You hear all these terms all the time and you're going, well, what's this phase stuff? I mean, what does that have to do with anything? Well, when you get to the human studies, they have to go through these phases. Phase 1 is where they take a few folks, a few brave folks. I mean, we're talking literally 20, 25 people. And they do an inoculation. Again, they've shown it's safe in animals. It does what we want in animals. So, all right, let's try it in a small trial, a phase 1 trial of a limited number, a few dozen patients. And let's see if it creates any problems right off the bat. Obviously, you can't say what's going to happen 10 years down the road. I mean, that's logical. But we want to know if it's immediately safe. More importantly, does it elicit the immune response in humans? Are we seeing these IgG and IgM antibodies, the little Pac-Man? Is that actually happening? Because not everything that goes on in animals happens in people. There's enough similarities that we can make some judgments, but not always. So you have to do this initial small study. And that's where all these initial vaccines are at right now. Now there is the group out of Oxford is beginning to recruit what they call for phase 2 studies. And essentially what that means is you've seen the data from the phase 1. You know, nobody had a leg drop off and nobody started shooting blood out their eyes. They did have a response to the antibody, to the antigen, an immune response. So, okay, it was okay in those dozen or 2 dozen folks. Now let's look at 500. Let's look at 1,000. And that's what's called phase 2. And again, you're looking for response. You're looking for safety. You're looking for the degree of response. And then you're also looking for the degree of protection. So that's where phase 2 kind of gets more into, okay, we knew it was in this small number. Let's make sure it's in a larger number of folks. And again, that's going to take several months. This stuff, I mean, there's no way around that. You just have to take the time to get the data to prove it's effective and to prove it's safe in the short term. Then, and that's 3-6 months minimum. Then you get phase 3. And that's where you start looking at larger groups of people, and you're looking at really, is it protective against the disease? And that's where you begin. I mean, these have to be very large studies. This is kind of the make or break. This is where you determine if it truly, okay, it's reasonably safe. It mounts the antibody response. Well, now can we show that people that get the vaccine are less likely to get infected as compared to people who don't get the vaccine? And as you can imagine, that's a whole different ballgame. That's taking a large number of people who are vaccinated but not infected, and a large number of people who are not vaccinated and not infected, kind of letting them do their thing, get their tattoos, go bowling, do all their stuff they're doing, and then be able to say, okay, the people who got the vaccine they ended up not getting the virus as often as the people who did not get the vaccine. So you can see that still takes some time. That's not something that just happens immediately. You can imagine the complexity of that, especially if you're trying to test it in a group. I mean, could you imagine testing this in Wuhan, China now, where a significant portion of the population has already been exposed? So where are you going to find the people who hadn't been exposed? Yeah, I guess you can go to some of their prisons, and they've probably all been exposed too, so, what the heck. But either way, this takes at least 6 or 8 months to do this correctly. Imagine where you're going to see this very much so is you're going to see a group that are tested, for example, healthcare workers, people who are going to be exposed. They'll have a cohort of people, of doctors, nurses, respiratory therapists, people who we know will be exposed, but who have not contracted the disease, inoculate a group of them, get a similar group of healthcare workers and don't give them, and then follow them over 4 to 6 months and see which one, if 40% of these folks test positive for COVID-19 and 2% of these do, then that's a really good sign that this vaccine is protective. It's doing its job, because you're comparing apples and apples at that point. But again, that takes time, 6, 9 months minimum. But that's what I suspect is going to happen and what we're going to currently see. As I said, there's 78 of these. There's 4 that are in phase 1, so we still got a ways to go. And as I mentioned, Seattle, Pennsylvania, Hong Kong, and Oxford are the 4 groups right now that are looking at that. And then it still has to go through the approval phase. Places like the FDA, the European Medicines Association, the National Medical Products Administration in China, they still have to approve it. It falls on their shoulders to approve and say it's okay to use this vaccine. The charge of the FDA is to make sure medicines and drugs are safe and effective. That's their charge. So that's all this testing, and then it goes to the FDA. Now, granted, the FDA has been granted some leniency in how to judge these vaccines. So my sense is that's going to be an expedited process. But it still has to go through that. Then it has to go through manufacturing. Then it has to go through distribution. Then it has to go through administration. In the end, my suspicion is, based on everything I've read, the experts I've read, even a couple I've talked to, I anticipate a minimum of 12 to 18 months before we have one of these vaccines that will be available to the general public. That's minimum. It may be more than that. So we're not going to have a vaccine, as people talk about this possible second rise in the fall, or this second distribution. We're not going to have a vaccine for that. That just forget about that. In September, October, November, December, if this rises again, hopefully we're going to have better treatments. We're going to do better with mitigation, but we're not going to have a vaccine. Probably 2021, we're going to be seeing a vaccine that's going to be available. Just like I said, swine flu, H1N1, it only took 6 or 8 months, but that was a completely different virus. It was very similar to what we'd seen before. So you were literally able to skip phase 1, 2, and 3 in human studies because it was a similar enough vaccine, and that's why they got that out in 6 months. This is, have you heard it called the novel coronavirus? Because it's new. We don't know that much about it. But there is optimism. We're going to get a vaccine. And it's going to be accelerated over the normal 3-4 years that it takes. And I think they're already looking at production, distribution, administration. They're doing that in concert with the research, anticipating, knowing that that's going to get to that point. So these processes are now, because of the accelerated need, working in parallel. Before, no one was willing to put in the logistics and infrastructure for those pieces unless they knew they had a good vaccine, that because it's usually done by a single company. Well, a lot of places are pooling resources and doing this other work in parallel. So we will get a vaccine. It will be effective. It will be safe in the short term. My belief is it's going to be similar enough to what we've seen in other vaccines that we can make some analogies and make some judgments about long-term safety. What it's going to come down to is people looking at the pros and the cons, looking at their risk factors. Certainly people who are at high risk, the scales are going to tip in your favor, I think, for most individuals who are at risk. There's a lot we don't know yet, because remember, we're in the very earliest part of this discovery. There's going to be a lot of information that's going to be out there between now and when we get to that approval time frame. So we're going to see a lot of information about safety and efficacy before then. There's some promising stuff out there on that second level I was talking about, the mitigation, the drugs to treat it, and the vaccine. This remdesivir, this antiviral, is showing some very promising information with regards to its efficacy. So I think that's going to be a real positive thing down the road. Still not sure. We're seeing mixed data on the hydroxychloroquine, and that, again, data's slowly coming out about that, and you've got conflicting reports about efficacy and safety. But I think what we're seeing with remdesivir, that's where I'm placing a lot more emphasis as far as treatment. One final word about a couple of studies that came out just the other day that I think are worth mentioning. One, both of these studies said that the number one comorbidity that puts you at risk for complications from COVID-19 is obesity, being overweight. And there's a number of factors that influence that. The study that really got my attention was in people under 50 who had the most serious complications. The one unifying problem was obesity. So we know that that has a horrendous effect on a lot of the things that this virus tends to latch onto. So my point is, there is something that you can do. You can begin to use this time to reevaluate where you are with your health. I'm big on wellness. Wellness has become my passion, and that includes a balance in mind, body, and spirit. And for a lot of us, weight is one of the biggest issues we face. My belief is that the best vaccine is the one you create in your own system. The best vaccine against this or any other pandemic is getting as healthy as you can be, at achieving that balance in mind, body, and spirit. That's going to protect you more than any drug, more than any vaccine. So my challenge to you is to use this time, this extra time that you have, to begin to think about ways that you can become healthier, to protect yourself, to provide a legacy for your family. That's one of the main reasons I went back and got board certified in bariatrics, in weight management, was to be able to provide that higher level service to people, because I realized that excess body fat, weight, is a trigger for a multitude of physical problems. And that was just reinforced by these studies, specifically as it relates to COVID-19. Look, if you're at a place where you're ready to say, I know that I need to do something about weight, that's why we have our program. We now are doing virtual visits. If you want to do a virtual consultation just to see what the program's all about and whether we can help you or not, just click on the little thing up there to do the virtual, and we can do a free consultation just to let you know if we have something to offer you. I'll tell you right up front, with most insurances, they're covering it if you have a comorbidity such as high blood pressure, sleep apnea, diabetes, joint pain, reflux, anything that weight loss will treat. Most insurances will cover this program. So if it's something that you feel you're ready, and you've got to be ready, you got to be ready here, and you got to be ready here. And once you're there, we can show you, we can walk you through, we can hold your hand, we can partner with you to do probably the single best thing that you can do for your long-term health, and that's get into a healthy percent body fat, especially as it relates now to this current pandemic. Well, I hope that's been helpful. Again, if you know of somebody that you feel like might be benefit from this information that we put out, being a part of our WOW community, we'd love to have them a part of that. Just simply click the invite up there and put their name in. I would love to see them be a part of this. If it's somebody that's meaningful to you, that's all I need. So until next time, say it with me, make healthy choices.